All right, guys, let's take a look at Unit 7, Lesson 11. Think about it. Shen is buying beverages for a party, which are individually packaged and come in packs of 8. I'm going to go ahead and underline packs of 8. The equation T equals 8P can be used to calculate the total number of beverages T when the number of packages P is known. So we know what T represents and we know what P represents. So A says determine the independent and dependent variables in the situation. I'm going to go ahead and say the independent variable is P. So write that in parentheses. I'm going to describe what that means. As we can see, it represents the number of packages. I'll describe why I chose P for independent variable in a second. And I'm going to call T, being the only other variable, the dependent variable. You know, T stands for total number of packages. So why did I pick P to be the independent variable? Well, because P helps to determine what T is. Since T is a total, it depends on how many packages we buy. Okay, so let's look at part B. Make a table using whole number values of P less than 6. So I'm gonna go ahead and label my table first. I'm gonna put P to represent that column and T to represent this one. Okay, it says P less than 6, which means it should be any number less than 6. So I'm gonna go ahead and put 1 through 5. 1, 2, 3, 4, and 5. All of these numbers are less than 6. 1 through 5 are the only reasonable values. Why? Because they're not going to give us half a package. They're not going to give us 0 packages. Cool? Cool. So now let's go ahead and create that equation to figure out what goes on in the T column. So the equation is T is equal to 8P. We're going to use some substitution here. For the first column, when P is 1, T is 8. When P is 2, T is 16. When P is 3, 24. Some of you may be asking if this is necessary. Yes, it is. Times 5, and we have 40. Cool. Let's go ahead and move on to the next part. Now it says graph the relationship between the number of packs of beverages Shen buys and the total number of beverages using whole number values of P less than 6. So they clearly want us to refer to the table above in part B. So let's go ahead and observe this table, this graph. Now on the y-axis, you guys notice that it's labeled as total number of beverages. So we know which column goes into that one. Yes, the second column, where it represents the T. The x-axis shows the number of packages. So I'm going to go ahead and put a T here and a P here. All right, so now we can look at our values in the table as coordinate pairs. We know that this point is 0, 0 for our origin. That doesn't need to be graphed though. That was just an example. 0, 0. Now we know the first point is going to be 1, 8. So I go to the 1 in the x direction, and I go to the 8 in the y direction. Same thing. 2, 16. 3, 24. Oops, that's ugly. 3, 24. 4, 32. And 5. All right, so this is a graph that represents the table above using the equation that they gave us. Now, we need to figure out what the key point is at this point. The situation shows us that a person is using packages and they're coming up with a total number of beverages. T is an independent variable, T is the dependent variable, and we were required to create a table and a graph. Now I want you to observe the graph. The graph shows our total number of beverages on the y-axis, and the number of packages on the x-axis. So when we're graphing, I want you guys to look at it this way. Whenever you're using a table or an equation to create a graph, any kind of relationship, we want to put our independent variable on the x-axis and our dependent variable on the y-axis. So I'm going to go ahead and write that down on a key point. You write this down as well. When graphing an equation, the x-axis represents, I'm just going to put reps, the independent variable. Independent variable, I'm just going to put IB. Save us some time. And the y-axis reps the dependent variable. Or you can put DV for short. Now that you have that information, let's go ahead and look at our interaction with new material. Now, none of you are present in a sense where you can answer the questions that I'm going to ask. So I'm going to ask a few of those questions to myself, and then I'm going to answer them as if I were you. So Zoe is collecting books to donate. She started with 3 books and then collected 2 more books each week. That first sentence tells me nothing, but the second sentence tells me a lot. So she started with 3 books. Let me go ahead and underline that. I'm just going to put a 3 on top of it, and then collected 2 more books each week. So 2 more books each week. Each week is very important. Create an equation and graph that represents the total number of books Zoe collected from week 0 through week 4. So the first thing we need to do is create a table. So I'm going to go ahead and create that table in vertical direction. Now, what goes where? We need to figure out what the independent variable and the dependent variable is. So I don't see anything that's labeled in here as variables. We have to create our own. So let's read it one more time. She started with 3 books and then collected 2 more books each week. So I underline each week for a reason. We're going to say that, let's say W, or let's let W represent number of weeks. Now we have to create another variable. So let's go ahead and pick T. Let's let T equal the total number of books. So one of these depend on the other, and we know that if there are a certain amount of books, it will be determined by the number of weeks. Okay, so let's go ahead and put those in our table. W is the independent variable, T dependent because it depends on W. So let's put a few values in. Now, what value should I use? Oh, wait, they said from week 0 to week 4. So let's go ahead and talk about it. Let's go ahead and input those. Week 0, week 1, 2, 3, and 4. So week 0, we're going to put a 3 for the total. Why am I putting a 3? Because she started with 3 books, which means if there are no weeks, she still has 3 books. Now, after 1 week, she has 5. So Note of an equation. Some of you might make the equation first, which is okay as well. Now that I have variables and I have some numbers, I'm going to go ahead and create my equation. So T, which represents the total, is equal to whatever we started with first, 3, plus 2W. So how do I know that this equation matches this table? Well, let's figure that out. If I say that W is equal to 0, my equation will become T is equal to 3 plus 2 times 0, which means that T is equal to 3 plus 0, which is just equal to 3. So when W is 0, T is 3. So basically by substitution, you all can test out the rest if you need to, but we're not done here. We have to actually use this information to create our table. Now, if you remember our key point, key point says that our independent variable goes on the x-axis and our dependent variable goes on the y. We determined that our W is the independent variable, so let me go ahead and label that axis. When I say label it, we're going to label it the number of weeks. I'm going to put in parentheses W. Our y-axis, which is represented by the dependent variable, I'm going to call that the total number of books. Which is labeled as T. All right, so let's go ahead and add some data to this table. So we know the origin is at 0, 0, so 0 here. And we know we're going up to 4, so let me just go ahead and scale by 1. So this gives me 1, 2, 3, and 4. Now observe the y-axis. How should we scale the y-axis? I'm just going to put a 5 here just to finish it up. We know that this part is 0 here. So can I call this 1, 2, 3, 4, 5? No, because our numbers go up to 11. So therefore I can't just scale by 1. So how about I scale by, what do you guys think? No response. Let's scale by 2, see what happens. 2, 4, 6, 8, 10. Does that work? Nope, it doesn't. Pretty sure I can fit it onto here. What about 3? 3, 6, 9, 12, 15. Now let's go back to 2, guys. See if that works best. 2, 4, 6, 8, 10. And we can use this last little line up here at 12. Okay. So let's observe. The first point is going to be at 0, 3. So that means we're moving nowhere in the x direction and we're moving up 3. If I'm not mistaken, 3 will be right here between 2 and 4 evenly. So about our next one, 1, 5. 1, count up to 5. 5 will be directly in between 4 and 6. At this point, you might find a pattern. 2, 7. 3, 9. Lastly, 4, 11.